This presentation is about the rock cycle and the Arizona Strip. It is part of the GED test prep class review of science for the GED exam. This lesson strives to clarify the origin of rocks by looking at the geological features of the Arizona Strip. Welcome to the geology of the Arizona Strip. We will review the variety of geologic features in this area of the state and the types of rocks found there. The Arizona Strip is located between the Utah border and the Grand Canyon. This high desert region features snow-covered mountains, arid desert sands, and colorful canyons. The rock cycle explains how the three main types of rocks are formed. Each of these main classifications are found on the Arizona Strip. Much of the rock found here is sedimentary rock created by the forces of erosion through wind and water. There are other examples of igneous rock formed by volcanic activity. And finally, there are nearby examples of ancient metamorphic rock. Mount Trumbull is an ancient volcano overlooking the Grand Canyon. Volcanic eruptions are evidenced by the lava flows surrounding the mountain, even spilling over into the canyon. Surrounding the mountain are many cinder cones that vary in size, including Little Cinder Mountain near Apple Valley. In geologic time, these eruptions are fairly recent. They compare to the eruption of Sunset Crater near Flagstaff in the 10th century. Local people create and relate stories of volcanic eruptions in their history. Igneous rocks are divided into two main groups. Molten rock that reaches the Earth's surface is called lava. On the surface, lava hardens into a variety of rocks that are classified as extrusive because they form on the crust. Basalt is an example of an extrusive igneous rock that is found locally in the lava flows. Notice the many holes throughout the whole rock where gases formed bubbles, creating holes as the lava cooled. Obsidian is also an extrusive igneous rock used by ancient people for points, knives, and scrapers. Igneous rock that hardens within the Earth's crust is called intrusive igneous rock. Granite is an example of this type of rock. If the molten rock called magma cools slowly into solid rock, the minerals will form crystals. The more slowly the magma cools, the larger the crystals will become. There's a great deal of evidence of volcanic activity in this area of northern Arizona. From our classroom window, we can see massive sandstone cliffs. Through uplift, erosion, and with weathering, the cliffs have been exposed over time. These cliffs are composed of sedimentary rock. They reveal cross-bedding layers and large solid blocks of sand deposited by wind, forming dunes. Other layers were produced by water, creating deposits along waterways and the sediment at the bottom of larger bodies of water. Sandstone is the most common type of rock on the strip surface. You might also find a rock roller among the sandstone. These round rocks probably started as small clumps of moist sand and minerals. Wind and water have rolled them around, picking up more material over time to form its spherical shape. Reaching elevations of 10,000 feet, the Kaibab Plateau rises above the Grand Canyon. But at one time, much of the plateau formed the seafloor of an ancient ocean. The limestone layers of rock throughout the plateau are also sedimentary rock. Because these sedimentary rocks were once underwater, fossils of ancient sea organisms are commonly found on the mountain. Looking south and west, the Arizona Strip disappears into the Grand Canyon. The mighty Colorado River erodes the rocks as it makes its way through the terrain, carrying away large amounts of sediment. Early settlers in the area thought the Colorado was useless. They said it is too thick to drink and too thin to plow. It is also very hard to get to. The dynamics of tectonic activity make the canyon a major fault. Also, the Kaibab Plateau has risen in elevation over time. All these forces have worked to create the canyon of today. As the Grand Canyon formed, rocks that were once buried deep in the crust have been exposed. These rocks are the third classification of rock, that is, metamorphic rock. Some of the oldest rocks in the world are found in the Grand Canyon. Because these rocks were buried in the crust, pressure and heat have changed the structure of the rock. Minerals within the rocks are compressed and bent. Some examples of metamorphic rock are slate, gneiss, marble, pyrite, quartzite, and schist. Any one of these types of rock can be recycled into one of the other types of rock through the constant processes of weathering, erosion, melting, cooling, heat, and pressure. Notice the constant changing of the rock formation as it recycles through the rock cycle. The Arizona Strip is a great place to study the dynamic history of the Earth and the rock cycle.